Thank you for your interest in this Geotech Center video on working with CAD data in ArcGIS Pro. My name is Wing Cheung and I'm a professor of geography and GIS at Palomar College. In this video, you'll learn how to import, georeference, and create world file for computer-aided drafting drawings or CAD drawings, as well as define projection and extract features from these drawings in ArcGIS Pro. If you wish to follow the demonstration that I'll go over in this video, please download and unzip the file from this web address. Be careful that it is case sensitive, the letters here. So you're going to want to save this file to your storage device and unzip it before proceeding with the demonstration. So to provide you with a little background, let's say you have been given a CAD drawing from your coworkers at the city's civil engineering department. They would like to see a GIS layer that only contains the ditch features from the CAD drawings that shows this housing development that is in the city of San Marcos, close to Palomar College. And this housing development is called Santa Fe Hills. So the first part of this demonstration, we will import the CAD drawings in ArcGIS Pro. Thanks to the direct read technology that ESRI and ArcGIS has built into it, there isn't really any additional steps that you need to take in order to read CAD drawings in ArcGIS. So as you can see on my screen, I have opened ArcGIS Pro and started a new project that's called CAD. And I've also, as I said in the previous slides, I've also downloaded the data for this demonstration and unzipped it and put it in the folder that currently holds this ArcGIS Pro project. So as you can see, here is the files that I unzipped, that I downloaded and unzipped. If I look inside that folder, you can see here is the CAD drawing that was given to me by the civil engineering department. Now, you can see here is the CAD drawing, but if I expand it, you can see that all the different features in the CAD drawings, whether it be labels and annotations or 3D features or points, polygons, or lines, have been organized into these CAD point feature class or CAD multi-patch feature classes. So basically, right, all the different features in the CAD drawings are organized into these CAD feature classes once it is opened in ArcGIS Pro. Alternatively, you can also use the CAD to Geodatabase tool in ArcGIS Pro to create a staging geodatabase. So to do that, if you go to Analysis, go to Tools, and look for CAD to Geodatabase, you can see here's a CAD to Geodatabase tool that will allow you to read the CAD file, that DWG file that I showed you previously, and then actually create a staging geodatabase with each of those CAD feature classes that I previously showed you, and turn them into a geodatabase feature class within the staging geodatabase. But for the purpose of this demonstration, we will just work with the original CAD file and the CAD feature classes as is. So to look at what these CAD feature classes look like in our map in ArcGIS Pro, go to Insert, go to New Map, and let's go ahead and add the polyline CAD feature class into our map by dragging and dropping it into our map. It may take several minutes because there are lots of features inside that polyline layer in the sample data set. Once the polyline layer is loaded in your map, you should be able to see it in your table of content. However, nothing has changed on your map, and this could be because, right, the CAD drawing, right, does not have projectional coordinate systems associated with it. So ArcGIS Pro does not know where to place it on the base map. And so we expand by clicking on this little triangle next to the layer name here. And then right click on one of the layers in this group layer and go to zoom to layer. We can see that indeed, right, the polyline layer has been added to our map, but it is ArcGIS Pro does not know where to put it on the base map, and it's just drawing it at some location in the map. If we zoom out, you can see that because of this lack of projection and coordinate information, right, this CAD drawing was actually placed off the coast of Africa. Right, or more accurately, off the Arabian Peninsula here in the Indian Ocean. So if we go back and zoom to the layer, right, there needs to be something that we need to do in order to put this CAD drawing in the correct location. And this process we'll demonstrate next in georeferencing. In the process of georeferencing, we will be aligning our CAD drawings with a layer, such as a base map, that has a known coordinate systems and projection. And in that process, basically assigning the coordinate information or the spatial reference systems, right, from the base map to the CAD drawings that previously does not have that information. So to perform georeferencing, right, back in ArcGIS Pro, right, we can right click on the polyline layer, zoom to the layer again, if you haven't done so already, and create a bookmark first. So I'm going to create a bookmark here called CAD. This will allow me to easily, right, zoom back to where the CAD drawing is. Next, to find where the CAD layer is supposed to go on the base map, right, or in other words, to align this CAD drawing that is clearly in the wrong location right now with the base map, you can go to Map here, click on Locate, and then we can search for Palomar College here and click on Palomar College San Marcos, because I know that this Santa Fe Hills housing development is just to the northwest of the campus. So let's click on the Explorer button to allow us to move to, right, the northwest corner of the Palomar campus. And so this, as you can see on my screen, is basically the general area that I know is covered by that CAD drawing. So I'm going to go to Bookmark and create another bookmark called Santa Fe Hills and click OK. And again, right, this allows me to easily, right, go back and forth between the CAD drawing and where Santa Fe Hills, right, and all of its features should be on the base map. Now, to initiate the process of georeferencing, let's first go back to our CAD drawing bookmark to see the the CAD drawing here. And next, right, making sure that Santa Fe Hills polyline is highlighted in your table of contents, you should see that there's a CAD layer menu here. Click on Tools, and you'll see one of the tools is Georeference. So click on that. And then it exposes, right, these tools like Add Control Points, which is the tool we'll use. So click on Add Control Points. And what you'll want to do is maybe zoom into the CAD drawing to identify some obvious features that you can see in the CAD drawing, but you can also identify that obvious features from the CAD drawing in the base map. So for my purpose, I can say I can probably find this street intersection on my base map. So I click once on it, go back to the map tab, go to the Santa Fe Hills bookmark that is showing, right, the correct location of this housing development on my base map, and basically try to find that street intersection from the CAD drawing in this base map, which is right here. You're going to need to repeat this process of placing control points on the CAD drawing and then finding its corresponding location on the base map for one more set of points. So I'm going to go back to my CAD drawing bookmark, and let's say here is another street intersection. So again, you need to have some patience here because there are lots of lines that are being drawn, and yeah, it takes a little time for them to show up in ArcGIS Pro. So here I'm going to click on this street intersection on my CAD drawing, go to the Santa Fe Hills bookmark, and look for that same street intersection, which is here. So once you have placed, right, this second set of control points, you can go to Apply. So go to the Georeferencing tab again if needed, and click on Apply to align the CAD drawing with the base map. So after a few minutes, right, you should be able to see now the CAD drawing showing up in the same place as the actual location of the Santa Fe Hills housing development on the base map, as you can see on my screen. The next step is for us to save this information. In particular, by hitting save here, we're creating something called a world file. And this world file basically stores the instructions for shifting or transforming our CAD drawing so that it aligns with our base map or any other types of layers that is already in the correct geographic space. Now that we have finished georeferencing our CAD drawings, right, by aligning it with the base map and creating, right, a world file to save this kind of transformation information, right, we still need to define the projection for our CAD drawing. So this is what we're going to do in part 3. Basically define the new projection for our CAD drawing based on the projection of the base map in which we used to align or place or georeference, right, our CAD drawing. So to define the projection and coordinate systems for our newly aligned CAD drawing, go back to this CAD layer section, click on Tools, and you'll see that there is a Define Projection tool here. So click on that. the Define Projection tool shows up. Make sure that your input is the Santa Fe Hills polyline layer. And you can see that the coordinate system, right, for this polyline layer, even though it's in the correct place now, thanks to georeferencing, it is still unknown at the moment. So we'll specify what is the coordinate system for this CAD drawing layer. And since we use the base map, right, as our reference for georeferencing, right, or shifting this CAD layer, we can just click on current maps here for coordinate system, right, and it populates for us the WGS 84 Web Mercator Auxiliary Sphere coordinate systems. Let's run that. And this basically defines or assigns this projection information and coordinate systems information to our CAD layer. So remember, the objective of this whole exercise is, right, to georeference our CAD drawing so that we can query and select out the ditches that our engineer coworkers want in a separate feature class. Right, so in this part of the demonstration, I am going to close out of the previous map we've been working on, start with a new map, add in the CAD polyline feature class to make sure that everything is right in the correct geographic space now that we have georeferenced it, and then use query tool and also selection and export tools to basically isolate out the ditches features into its own layer. So back in ArcGIS Pro, I'm going to close out of the map that I've been working on. And I'm going to go to the Insert tab and start with a new map. I'll go back to the catalog pane, and let's just drag and drop polyline into our map. And we should see momentarily that the polyline layer should be shown in the correct geographic space because we have georeferenced it and defined or created a world file for it, and then also defined its projection. So don't be alarmed, right, if your screen looks like this, because if you look really closely or if you zoom in to this where my pointer is, that is actually where the CAD drawing is being drawn as we speak. So if I zoom in here, you can see, right, the CAD drawing now is being shown in the correct location and no longer off the coast of the Arabian Peninsula. If you look at our layer here in ArcGIS Pro, or expand that group layer in the Content tab, you can see that there are many types of lines that is in this group layer, right, that are all showing different polylines in the CAD drawing. So in order for us to query and single out only those lines that represent ditches, because that's the objective of this whole exercise, right, we will go to Map here and go to Select by Attribute. And here for layer name, make sure that you select the polyline layer. And we're creating a new selection. Go to Add Clause. And the field that I'll use here is layer, the layer name. Just equal to, and look for ditch here in the drop down. So here it is. Click on Add, and then click Run. So as you can see here, the process or the operation has completed successfully. If we look back in the table of contents, right, we have a lot of other layers that we're not using. So I'm going to just remove them for the meantime right, in order to improve our performance, because we're really just dealing with this polyline layer. So I'm just going to hit this first one in the list, hold on to the shift key, right, scroll down with my mouse to the bottom of the list, or here. And let me just here to highlight all of these, as you can see here, because I'm really just working with the polylines layer. So I'm going to right click on the selected layers within this group layer and just remove them, just to help me increase my performance a little bit. Turn on my polyline layer, and so I can see what has been selected as a result of my attribute query. And so you can see here, all the line features in the polyline layer that correspond to, or that has a layer name of ditch, is now selected. So what we will do is export those selected line as its own feature class. So right click on this polyline layer, go to Data, and go to Export Features. In this geoprocessing window that opened up, make sure that the import features is the polyline layer, and I'm going to name my output feature class ditch, and hit run. And now if I go back to my map and remove the polyline group layer, you should see now I have the ditches feature that were previously selected and are now exported into its own layer in my map. So I hope that all of you find this video informative, and I thank you for joining me. Please see the Geotech Center website for more demonstration videos, or to learn more, you can find other resources on the Geotech Center website. My name is Wing Cheung, and I'm a professor of geography and GIS at Palomar College, and also an assistant director with the Geotech Center. Thank you.